So I have a little bit of a break. All right, quadratic functions, chapter 2. Thank you, All right, so chapter 2 is all about polynomial functions. And quadratic functions are a special kind of polynomial function. So let's write down, we'll do this, we'll talk about this quite a bit this chapter. So a polynomial. We've talked about polynomial functions here and there over the course of the first semester. What do we mean when we're talking about what is a polynomial? Multiple terms. Poly means many, right? So I have a bunch of terms. So a polynomial is a function with a bunch of terms. So we're going to make the definition a little more precise. So we're going to say a polynomial function is a function where we can write it like this. A sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus dot dot dot, plus a sub 1 x, plus a sub 0. So we have all these powers of x, these numbers in front and powers of x. And for a polynomial, we're going to say that all of the a's, all of these a sub i's, are real numbers. Things get really interesting when you let the a's be complex numbers, but we're just talking about real numbers. So, and then n is a non-negative integer. So we have either 0, and 0 is non-negative, so these could be 0, and then all of our exponents, essentially what we're saying here is all of the exponents are positive. So we have 3x cubed plus 5x squared plus 7x plus 1. That would be a polynomial. So polynomials have these terms, bunch of terms with positive exponents on our variable. What happens if n, our highest exponent, because we started at the highest exponent and then our exponent gets smaller and smaller. So when we did the binomial theorem, we expanded and we ended up with a polynomial. So we had all these positive exponents. So what happens if n equals 0? Our highest exponent is 0. What kind of function do we have? If n is 0, we don't have negatives, so all of these other ones go away. What's x to the 0 power? 1. So we have whatever a sub n is, whatever this number is, times 1. So we just get a constant. So if our highest exponent is 0, we just have a constant function. F of x equals 2, something like that. What about if n equals 1? What happens if our highest exponent is 1? What kind of function do we have? F of x equals 2x plus 3. What is that? A line. That's a linear function. And study a lot of linear functions in algebra. We like when we have linear functions because they're well behaved. What we're interested in today is if n equals 2, our highest exponent is 2, we have a quadratic function. And we usually write our quadratic function, hopefully this looks familiar to everybody. We would say f of x equals ax squared plus bx plus c. That's how you usually see a quadratic function written, and we call this the general form. That's our general form of our quadratic function. And we also want, in our general form, a not equal to 0. Because what happens if a is 0 there? This first term goes away, and we just end up with bx plus c, and then we get a linear function. So we want a quadratic function, not a linear function. So if a is 0, we get a linear function, so we don't want a to be 0. All right, so we're good with what we mean when we're talking about a quadratic function. Our highest power is 2. The doors open to the math office. They thought something was wrong. All right. What kind of graph? What kind of graph is does a quadratic function give us? Parabola. Parabola. Graph is a parabola. So our graph is a parabola. And I'm just going to write, so we have y equals ax squared plus bx plus c. What does, so our parabola, y equals, we have something like y equals x squared. We graph y equals x squared, just, that's our easiest quadratic. So if we graph this, like so, that's more or less what our parabola looks like. What do we call this point here? It's at the origin, but what part of the parabola is it? The vertex. That's the vertex. And if we draw this, parabolas have this nice symmetry. If we draw them perfectly, so if we draw this line right down the middle here, we call that the axis, or the axis of symmetry. So the symmetry is one nice thing about parabolas. So we have our vertex and we have our axis. And if we look at our general form, how do we know if our parabola opens up or down? If A is positive, then it opens up, and if A is negative, it opens down. And towards the end of the semester, we'll come up with a way of describing parabolas that open left and right as well. So the vertex and the axis of symmetry, notice the axis of symmetry goes through the vertex. The vertex and the axis of symmetry are an important piece of information to have about quadratic graphs of quadratic functions. So we want, from looking at this equation, we don't really know the vertex or the axis of symmetry. So we want to be able to figure that out if we want to look at the graph, if we want some more information about it. So what we want to do in that situation is we want to look at what we call the standard, or the book calls it standard form. We'll normally call it the vertex form. You'll usually hear it referred to as vertex form, but our book calls it the standard form. So we want to be able to write this in a form that gives us some more information about our parabola. So our standard or vertex form is going to look like this. F of x equals a x minus h squared plus k. And when we write our vertex in this form, the vertex is at the point h, k. And the axis of symmetry, or the axis, and the axis is a line. The axis is x equals h. So that the axis always we always end up with an equation of a line. Yes.
So if like the standard form is written as like something x plus 3, does that mean that h is negative 3?
Yes.
Okay.
Mm-hmm. So yeah, with this part that's in the parentheses, when we get the coordinate of the vertex, essentially we change the sign.
Okay.
And what does the h tell us about the graph of our parabola? Thinking about how functions transform, shifting, stretching. What does the part that's with the x tell us to do with the function? Move it, which direction? Yeah, Macy does this, left or right. This is going to move our graph left or right, and the k moves it up or down. So this tells us how our parabola is shifting from the origin, left and right, up and down. And our shift here is, so we think of it kind of as the opposite. Just like we did with trig functions, just what we've done with transforming other functions. And what does a do to it? This gives us a stretch. A stretch or a compression. All right, so let's talk about how we get to, and let's write this down. We talked about it. If a is positive, what does that tell us about the parabola? Opens up. And if a is negative, opens down. All right, so now we need to know how, if we have the general form, how do we get to the standard form? How do we get to the vertex form? And just to note, this a that's out here in front of this x minus h squared, it's easy to forget that. Don't forget that there can be a number out there. And we'll talk about a couple of problems where that comes in. All right, so let's look at an example of how we get from general form to standard form to vertex form. And hopefully this brings back some very fond memories of some days in algebra. So we want to find the vertex. And the axis of this function f of x equals x squared minus 4x minus 2. So I have this general form, and we want to find the vertex and the axis. What this problem is actually asking us to do, and you'll be asked this question lots of different ways. What it's asking us to do is put this equation in vertex form. That's what this is asking us to do, is put this in vertex form. Do we remember how to change a quadratic function from general form to vertex form? It's something that I'm sure you love to do in algebra too. To do this, we complete the square. Do we remember that? Completing the square? Putting our quadratic function in vertex form? Solving our quadratic function by the square root method? We need to complete the square. Yeah? Bring back vague memories. It's kind of quiet. All right, so when we complete the square, what I always do when I complete the square, x squared minus 4x minus 2. I always put parentheses around the x squared and the x part. That's the part we're going to complete the square on. We work with this part. All right, to complete the square, a little reminder here. We take whatever the b value is here, whatever the number is in front of the x. We divide it by 2 and square it. So negative 4 divided by 2 is negative 2, and we square that and we get 4. And I'm going to write my minus 2 out here. I've added 4 here, so to keep everything the same, I have to subtract 4. So I've essentially added 0, but I do it in a convenient form. So when we complete the square, as a reminder, we take whatever number's in front of the x, divide it by 2, square it, and then we add that to our function. But we also have to subtract it because we don't want to change the value. And we do that because that turns this part in the parentheses into a perfect square. So how can we factor x squared minus 4x plus 4? X minus 2 times x minus 2, which is x minus 2 squared. And I have a minus 4 and a minus 2, so I have a minus 6. And if I squared this out, if I FOILed this out and then simplified, I would end up back here. And now we know where, so where's the vertex? 2, negative 6. And so this parabola is shifted 2 units to the right, 6 units down. And where's our axis of symmetry? X equals 2. On some of the problems, you will be asked to find the x-intercepts, or you'll be asked to sketch a graph. The x-intercepts help us to sketch a graph. So let's, if we had been asked, where do we find the x-intercepts of a graph? When y equals 0. The x-intercepts mean where it crosses the x-axis, so when y equals 0. So the x-intercepts, we can set y equal to 0, or f of x equal to 0. So the x-intercepts, and that will help us sketch it. We would say that 0 equals x minus 2 squared plus 6. Sorry, minus 6. And then we solve for x. So add 6 to both sides, so x minus 2 squared equals 6. Take the square root of both sides. So x minus 2 equals, what is it? Someone said it? Plus or minus. We have to do a plus or minus here. Very good. Not 6, but square root of 6. And then we add 2 to both sides. So x equals 2 plus or minus the square root of 6. And so if we had to sketch a graph, we could use our x-intercepts. So we'd go over here to 2, negative 6, put our vertex, and then 2 plus square root of 6 would be over here somewhere. 2 minus square root of 6 would be over here somewhere. Square root of 6 is a little bigger than 2. And then we could sketch a graph of our parabola. And we know it opens up because A is positive here. A is 1. So this point, if we were to label this, this would be 2 plus square root of 6, and that would be 2 minus square root of 6, and this would be 2 negative 6. So there's a rough sketch of that graph. That bring back some memories. All right, questions on that one? Let's look at another one that we have to do a little more work for. let's find the vertex. This question asks it, find the vertex. Of this quadratic function, f of x equals negative 2x squared minus 4x plus 1. So I look at this one, what don't we like about this one? What the whole thing? That's what somebody said? After we get over our aversion to the entire thing, what's the second thing that we don't like about this one? It's got this negative 2 in front of the x squared. So we're still going to complete the square using just this x squared part and this x part. But I'm going to factor this negative 2 out first. So I'm going to say this is negative 2 times x squared plus 2x, and I'm going to put the plus 1 there. And I'm going to complete the square on this part in the parentheses. But I got rid of that negative 2. So we do the same thing. I'm going to say this is negative 2 times x squared plus 2x. And I divide this by 2. So 2 divided by 2 is 1. 1 squared is 1. So I add 1 there. And I still have this 1 out here. But now I have to be careful. What is this negative 2 doing to the parentheses? Multiplying. Multiplying everything in the parentheses. The negative 2 is multiplying this 1 here. So I've not added 1, I've subtracted 2. Because negative 2 times 1 is negative 2. So what do I have to do out here to undo that subtracting 2? Add 2. This negative 2 multiplies a negative 1. So I've essentially added negative 2. To undo that, I have to add a positive 2. So I end up adding 0. I'm not changing it. So when we have this leading coefficient, this a value, make sure that when you complete the square, after you factor that out, that you take that into consideration when you add this or subtract whatever number out here. So now we're set. Negative 2, and how can I write this x squared plus 2x plus 1? X plus 1 squared. Now if you complete the square and you don't get a perfect square, something that you can write like this, you've done something wrong. That's the point of completing the square, so we can do this. And then we get plus 3. So our vertex is at, second number is 3. Negative 1, 3. There we go.
Why don't we just factor in negative 2?
So let's go back here. Remember, our vertex form is a x minus h squared plus k. So we don't want that a in there at all when we're looking at the vertex form. And this parabola would open down, and a vertex would be at negative 1, 3. And if we needed to, we could sketch a graph. We could find the zeros and sketch a graph. We'll plug in some x values to get a couple of extra points to sketch a graph of this parabola. So when we do have a leading coefficient here at this a value, we have to be a little more careful when we complete the square to make sure we take that into consideration. All right, questions on that example? All right, let's look at a third example, slightly different type of question. And we'll talk about a little shortcut for finding the vertex. We want to find the standard form. So we have this parabola with a vertex at 1, -2, and goes through the point 3, 6. So we want the vertex form, standard form, vertex form. And we know the vertex, and we know our parabola goes through this point. So a little different type of question. Well, let's write out the vertex form without any numbers in it. Our vertex form was a x minus h squared plus k. But don't we have some pieces of this equation? What the vertex gives us h and k, right? This is h and this is k. So let's write our vertex form with h and k in there now. So f of x equals a x minus 1 squared minus 2 plus -2. Now our problem is just to find a. And this is where a lot of students like to forget that there's an a value. We have an a value. How can we find a? What does this point give us? An x and a y, right? X and y is the same as f of x. So I can plug those numbers in here. So I have f of x is 6 equals a times 3 minus 1 squared, that's x, minus 2. So 6 equals 3 minus 1 is 2, squared is 4, so we get 4a minus 2. So 4a equals 8 and a equals 2. So my vertex form, we want the standard form, the vertex form. Our standard form is f of x or y equals 2x minus 1 squared minus 2. And we're set. Sounded complicated, looked like it could be difficult, but not too bad at all. All right, questions on that one? And we did some similar. This is kind of like the problems we did with arithmetic and geometric sequences, where we knew the third term and the seventh term. It's kind of the same. We have two different pieces of information that we have to use for two different parts of the problem. Same kind of idea. All right, one last topic for today. Maximums and minimums. So if we have a quadratic function, if we have a graph of a parabola, where's the maximum or the minimum of that going to be? Top and bottom. And what part is the top or the bottom? The vertex. Who said vertex? Very good. The maximum or minimum of a quadratic function is going to be at the vertex. I'm just going to say max or min is at the vertex. So if our parabola opens up, it's going to have a minimum, and the minimum is going to be at the vertex. If our parabola opens down, our quadratic function is going to have a maximum, and the maximum is going to be at the vertex. So if you get a problem that asks you to find the maximum or minimum value of a quadratic function, is asking you to find the vertex. That's another way of asking you to find the vertex. A shortcut to find the vertex. So if we have f of x equals ax squared plus bx plus c. The vertex is at the point negative b over 2a, f of negative b over 2a. So the vertex is here. The maximum value is asking you for the function value, for the y value. So if the problem asks you for the maximum value, it's asking you for the y value. So the maximum value is the y value. The vertex gives us a point. The y coordinate of the vertex gives us the maximum or minimum value. And we can use this to find it. Yes?
How do you find that?
F, this is F. So what this is saying is if you have a quadratic function, find negative b over 2a, just plug those numbers in, and then whatever that number is, plug it into the function and calculate, and that's your f of negative b over 2a. So if negative b over 2a turns out to be 2, you plug 2 into your function, and that would be the y coordinate of your vertex, and that would be your maximum and minimum value. And interestingly, this comes from completing the square on this quadratic function, which is the a's, the b's, and the c's in there. So if you want a fun little thing to try to do is complete the square on this to get to here. Not too hard. It's kind of nice. Everything is nice. If it's math, it's nice. That's like an axiom. If it is math, then it is nice. It's like a conjecture in geometry. What's that? This would be an axiom. An axiom is something we accept without proof. If it is math, then it is nice. That's our axiom. All right. I will not let you forget. Because your nightmares will turn into lovely, pleasant dreams of of math. All right, questions? Okay. We're done. There's not one more thing this time. All right, there you go.